Hello all, welcome back. In this video, I'm going to explain Agentic AI using one clear real-world example. I'll take one system, break it down into 5 core components of an AI agent, step by step, in a way that anyone can understand. Before which, an Agentic AI means an AI system that can work towards an independent goal. They don't just give us outputs, they observe, decide, act, and learn. Merely saying AI with goals, actions, and feedback loops are agentic AI agents. There are 5 important core components of an AI agent in agentic models. Number 1 is a goal. Number 2 is the environment. Number 3 is the perception. Number 4 is decision or policy, followed by number 5 is action. What it wants is a goal. Where it operates is the environment. What it observes is the perception. How it chooses is the decision, and what it does is the action. So the example that I have taken here is a simple smart city flood management system. So now let us understand the components 1, 2, 3, 4 and 5 individually, right? Getting into the example. The first component is goal. Every agentic AI system starts with a clear goal. The goal of our flood management agent is simple but yet very powerful. To minimize flood damage by detecting early risks and taking preventive action automatically should be the goal. This goal is not just a one-time task, it is continuous. Right. The agent does not stop after making a prediction. It keeps working until the risk is reduced. So this is what is making the agent agentic. In simple words, the agent always know why it exists. The second important component is the environment. The environment is where the agent operates. In this example, the environment might include rainfall sensors, river water level sensors, soil moisture data, weather forecast, drainage system status, and even historical flood data. So all these environments are dynamic, not static. So conditions changes every hour. Even few minutes, these conditions will change. For example, rainfall increases, water level rises, the drainage system might fail. So such kind of agentic AI must continuously deal with change. So that is why we say an agent lives inside a changing environment, a dynamic environment. The third component is a perception. Perception is how the agent observes the environment. The flood agent could observe current rainfall intensity, the rate of water level rise, blocked drainage alerts, weather warnings, and even its own past prediction errors. Importantly, perception is not just raw data. The agent converts data into meaningful signals, right? For example, the agent, if the water level is rising faster than normal, the agent should interpret this as an early danger signal. So perception is just not seeing, it is understanding. Number 4 is decision making or policy making. This is the brain of the agent. So based on what it has observed, the agent must understand, should I increase monitoring? Should I trigger an agent? It asks itself, should I activate the drainage system? Should I switch off to a different prediction model because of an error? Or should I ask for human intervention? So this kind of decision making can be rule based, machine learning based, reinforcement learning based, or even a hybrid approach. For example, even if small rainfall change is noted, say for example it is only moderate, but even if during moderate rainfall conditions the drainage systems are blocked, for example, the agent may decide that flood risk is high. So agentic AI does not just ask what is happening, it will ask what should I do next. This is an important component. The last component is action. So after making a decision, the agentic AI agent must act. So in this kind of a flood management system, actions might include sending early flood warnings to citizens, or activating smart drainage gates, deploying emergency teams, collecting additional data, retraining its prediction model. So prediction alone is not enough here. So this is a very important point. Prediction alone is not important here. An agentic AI system that only predicts is not an agent. An agent here must act. So there is a feedback loop also. You should have seen. This feedback loop is again important. Very important part here. After taking the action, the agent evaluates the outcome. It again asks itself, did flooding actually occur? Were the alerts sent on time to the citizens? Were there any false alarms? Did my action reduce damage? If the alerts were too late, the agent will learn to act earlier next time. Maybe if there were too many false alerts, the agent adjusts its decision threshold. This ability to learn from consequences is what makes the system truly agentic. So to summarize, the flood management agentic AI has a goal which reduces flood damage, an environment which is a smart city sensor and data, has perception which understands the risk signals, has decision making capability, means choosing the best response, has action, meaning alerting, controlling, and adapting the system. All of this will run in a continuous loop. So only if this is running in a continuous loop, we call this to be an agentic AI. So agentic AI is not about smarter predictions. It is about responsible decision making in real time. Hope this video will make you understand what is agentic AI agent. If you want a simple implementation of the same, do post it in the comment. I'll be happy to do. Thank you. Happy learning.